Good morning, dear students. In our last class, we have discussed about phases. Hope you have got too much information about phases and the phases are very clear to you. Today, we are going to discuss about component. That is also a very important thing to study the phase rule. Okay, so let us first see the definition of components. What are components? The smallest number of independent variables, constituents taking part in the state of equilibrium, by means of which the composition of each phase can be expressed in the form of a chemical equation. What does it mean? It means that if we are considering any equation or any reaction and that is present in an equilibrium condition, then what are the phases present in that equation? We can easily find out the composition of those phases. And that composition is given by the chemical formula of those substances that is present in the equilibrium condition. Okay, so in simple language we can say that what are components? Components are the independent identities and they have a separate chemical formula. They can be expressed by a separate chemical formula. Okay, let us take some examples with the help of which it will be very clear to you what are components. We have discussed phases, so side by side I will again repeat the phase also. Suppose I am taking a salt solution. I have taken a glass of water and pour some salt in that, NaCl salt simply. Now that NaCl is totally mixed in that water to make a homogeneous solution. How many phases are there? Single phase, because we could not see where is salt. So it is a single phase example. Now what are the components? How many components are there? It has two components because NaCl and water both are expressed by different chemical formulas. Okay, so how many components in this system? It has single phase but two components. Let us take one more example. Again the same glass of water. I am pouring salt. I am pouring sugar to it. How many phases? When all these salts and sugar are dissolved in that water, then how many phases? A single phase, a homogeneous mixture. But how many components? Three components. Sodium chloride, that is represented by NaCl, sugar, that is C12H22O11, and the third is water. So a single phase but three components. So hope that component is clear to you. Again, one more example we can take. We have studied about the water system. Water system is making an equilibrium condition at triple point, and at triple point that is the particular condition I have shared to you. It exists at 0.0098 degrees centigrade temperature and the pressure is 0.006 atmospheric pressure. At this condition, the water system has three phases. Ice, it exists in ice form also, it exists in vapor form also and liquid form also. Okay, so how many phases? Water system has three phases at triple point. But how many components? The components are single because we don't have any formula to represent ice. We don't have any formula to represent the gaseous state of water. We will be simply writing for ice, for vapor as well as for liquid water, we write H2O. Okay, so how many components? At triple point, one component and three phases. Okay, now one more example let us take. Let us consider the sulfur system. Now the sulfur system has at equilibrium condition four phases. What are those four phases? Rhombic sulfur, monoclinic sulfur, liquid sulfur and vapor sulfur. If we are going to represent these phases by a formula, what formula do we have? We have single S. S represents sulfur. Sulfur monoclinic, sulfur rhombic, sulfur liquid, sulfur in gaseous phase. So four phases but component is one because all of them can be represented by a single chemical formula and that is S. So in this way, in equilibrium conditions, in any reaction, in any system, we can find out the number of components. Let us one more example. Suppose I am taking an alloy of copper and silver. Now an alloy of copper and silver, the solid phase if I am having, then copper and silver are mixed very well with each other. We could not identify where is copper and where is silver. So single phase. But how many components? Two components. One representing Cu, another representing Ag, that is silver. So just by looking at the chemical formula, we can identify the number of components in any system. Hope by these examples you will be having no doubt to identify the components in a given system. Now in next class we will be studying another important identity about phase rule, and that is degree of freedom. For today it is over all from now. Have a nice day.